Good morning. Thank you very much for joining us this morning. It's rather early. I need to wake up still. But I'm Siamak Tavalai. I'm a chief architect within Google team. I have here Mark with me.
So I'm Mark Shaw, I'm a principal architect at Microsoft.
It's been a while. We've been working together from Microsoft team and Google team on some modular hardware systems. As you guys know, we started with DC-SCM in 2019. That was the definition that we had for a modular building block architecture. We introduced concepts at the time and invited participation from the community. And it was great that a lot of people saw the reasons that we were doing it and agreed with that and made it happen, basically. We published DC-SCM 1.0 spec already, and work is underway for DC-SCM 2.0. But since 2019, some other things have changed also, and we have learned from that. So we're going to share that a little bit with you and project what we're doing next year. So when we started, we had the definition that, hey, you start with a motherboard, take out the essential elements around the processor itself, DIMMs, I/O slots, put it away and put it somewhere else, call it host processor memory module. Whatever left was the heart of the motherboard. And that was the definition of DC-SCM. And then later we defined the interface between DC-SCM and HBM called DC-SCI. And most of the specification was around that. Since then, we realized that, well, we also need to have a system around it. So thinking about that and learning from experiences in the past, we came up with a concept that is an integrated system. We call it DC-Stack, data center ready stack of hardware and software. We presented that one to OCP server project. It is on the wiki. You have access to it if you like. Hopefully, we will add software to that modular system and eventually go to DC-Stack. Conversation today is mostly around the hardware first. This afternoon, we have a session around the software aspects. So why did we do all of this? We wanted to create a smooth pathway from innovation, from production to deployment into data centers. We want to create a win-win situation for not only suppliers, but also consumers. Suppliers, whatever they build based on a reference design, could sell it to multiple end users, and end users would have the choice of selecting from multiple suppliers. So that was a win-win, and once the system is complete, it can be deployed into data center faster. When I say data center here, I mean hyperscale, enterprise, or edge data centers. All of those are important to us. And OCP provided the legal framework, this community for us to work together, collaborate. Sometimes even competitive companies joined the development, and that worked well. In contributions, we have asked for people to bring something, either the new technology, new ideas, new requirements, help writing specifications, provide POC funding, do the POCs or reference designs. In whatever ways the community can contribute, we welcome that. So in the past couple of days, you guys probably have seen this chart. It shows that we started with DC-SCM, just a specification for the interface, and then the module was built on top of it. What we are about to do is come up with a specification for a system around DC-SCM, and then at some point, suppliers will build systems to go along with that. Later, we will add software ingredients on top of all of that, and we call that DC-Stack. Once we're done with all of that, we will give that one to another initiative within OCP called Cloud Service Model. Those guys are defining requirements from top down, from the data center looking into these system chassis, what requirements need to be there. So hopefully we can meet in the middle and everything will work. So as we were doing that, we saw that we were not alone. There are a lot of other ingredients being worked on. Within OCP, there are multiple projects that are aligned with this concept. You guys might be already part of those teams. We already work on DC-SCM, the interface XPI. We have published a version of that already. It is on the project server wiki. Modular hardware system is the conversation we're having right now. And then firmware is important, so open system firmware is active, security project, test and validation. Actually, there is a very nice talk today by Dan Frame and his team on test and validation. Please attend. And then we'll give the whole thing to eventually cloud service model. One other aspect that you guys have heard, sustainability is important. So this year, we're going to focus on that as well. Suggestions have been that immersion cooling will help with sustainability. So as we come up with a specification for modular hardware system, we will follow the guidelines that OCP team has created for material compatibility, as an example. So when we put all of that into a flywheel, we call it the flywheel of success, bring in hardware, bring in software, bring in test and validation, and have the sustainability in mind, we believe we can be successful. Successful in doing what? Allowing innovations find their ways into hands of eventually customers, be deployed faster into data centers. That creates the win-win that we've been looking for. So hardware is not the only requirement. We also need to have software. What has happened in the past was that for different use cases, we've had to create different software stacks, different management, different security, different testability and diagnostics and debuggability. Because individual hardware pieces were very different, we had to have multiple stacks. So within this modular concept, the goal is to come up with one definition for software infrastructure and apply it on the modular hardware system so that we could have one stack. Again, that is for the goal of getting to the market faster. So again, in summary, we could say that this data center ready integrated system designed for edge, enterprise, and hyperscale data centers consists of hardware, software, management, and infrastructure. And we organize that one based on our learnings from past OCP experiences. We have had modular systems already. OAI, Open Accelerated Infrastructure, was a concept that was modular. Again, 2019 and 2020, we work on that, and there's an active project. Later this afternoon, there are a number of workshop sessions on that. So we follow the main concepts that we've had within the server project. Base specification defines the architectural framework. Based on the base specification, multiple designs are possible. Based on each design, multiple products are possible. So that is still the pathway we're taking. It was important for us to categorize the modules, give them names, identify roles and functions they had. So we thought if we're in physical domain, we think about DC-SCM as one major module and a host processor memory module as the compute element that could have CPUs or GPUs or other accelerators on it. And then interconnect between that and the I/O module, the modular I/O, DC-MIO, and the interface DC-XPI. And we also recognize the new important place for SmartNIC. It's evolving. Different people call them different things, DPUs, IPUs, or SmartNIC. But we need to recognize that position and overlay that with logical concepts, security, manageability, debug, power, cooling. That becomes a modular hardware. So for that, we have come up with some taxonomy so we can identify the work that we need to do, organize our work. High level, DC Stack is the umbrella. For that, we need software, Hyperstack, is the software ingredients, infrastructure software. And the hardware elements we have identified here. What's important for us is after identifying the individual components, define clearly the interfaces between them. So some of the work that we will do is to standardize on these interfaces. We don't want to come up with new standard necessarily if there is a standard out there that's already useful. So we start with what's available. We may identify very soon that certain things are not covered by the industry already. We will define those, and once they're complete, as an independent contribution, we will introduce those so they can be used in a modular way in different applications. So that is the plan that we're having with the whole concept of modular architecture. So once we are successful, we could see that suppliers on their own can build systems as a collection of all these modules, test, validate, qualify on their own based on the software stack that will be standard, that we will work together. Google will have some participation in that. We have a test suite already. We're thinking about opening that up. Please come to the session this afternoon. Towards the end of the day, more conversation will be around that. So with that, suppliers can actually build these things on their own. But then, if customization is necessary, customization can be done in a modular fashion because interfaces are defined. That's the whole story. So you start with a system that's already complete. Suppliers can sell them to whoever they want to, but they can customize it based on what an end user, an OEM or a hyperscaler or a data center that builds to edge might need. So on top of hardware, there are some software ingredients. Again, please come this afternoon to talk about software. And on top of all of that, we'll have to have a compliance test suite. So as I suggested, individual companies have these test suites already. They're working. What's in front of us is bringing them to the open, making an open source version of those, get the community involved, fix them if they are not complete, change them if they need to be changed because new technologies show up. So if we were to put all of these things together, we can get to that flywheel of success. We take advantage of the industry effort, PCIe 6, CXL Consortium, SNIA, NVMe. New technologies show up. We add some value to it, software ingredients, hardware ingredients, enclosures, put them into this flywheel, modular hardware, modular software, test and validation, open system firmware, and then satisfy the needs of data centers, edge data centers, hyperscale data centers, and enterprise. Again, all of those are built on the OCP concepts that we've had. You have requirements. Based on requirements, you come with base specification. Base specification defines design specifications. Design specifications are more detailed. And then later, products are built around that. And you ship it to the customer, and hopefully the customer will be happy. And it's very similar to when a composer gets inspirations, conductor makes interpretations of the composition, and then musician plays and have different interpretations of that, and the audience will enjoy. So with that in mind, I'll give the mic to Mark. He's going to cover some of the things we've already done and progress report.
Yeah.
Please.
So Mark Shaw, I'm an architect with Microsoft. Shyam's a very elegant speaker. I'm probably a little bit more brute force. But thankfully, what I'm going to kind of show and talk about is hardware, which is what I like to look at. So as we're talking about modularity and getting from point A to point D, points B and C are super important, right? If we don't have the hardware and the ecosystem, the infrastructure set up to become modular, modularity becomes a disaggregated fraction thing. So we want to talk a little bit about some of the ecosystem that's been set up. So step one, right? If you're going to be modular, you want, you want something to be able to do A, B, and C, and D. You have to have an ecosystem for which it can do that from. That starts for us with a connector. So you're going to hear Nilesh Dattani, some other people talk about DC-XPI a little bit later today. Basically, what you see here is a replacement. Prior motherboards all had PCIe connectors. PCIe connectors are great for sticking PCIe and PCBs in. What we wanted, and we kind of formulated a number of years ago working with EDSFF, was an ecosystem in which, hey, this connector can accommodate not just the signal integrity requirements of tomorrow up to 32 gigabits per second or further, but they can plug in PCB boards in terms of cards, or risers that are very popular to be used, or cables. Right, and that was the key, right, was getting to something that I could plug PCBs and cables into, because now I've got an ecosystem in which I can be a little bit modular, and I can be, I can go a number of different ways with it, and I can, from one motherboard, create multiple different use cases for my front I/O. Now, what you see there is just an example of a riser board in, but that connector also accommodates readily cables, as we're about to see here. So here is a not Microsoft system, right? So I'm not just showing off my things, I'm showing off something that somebody else did, right? Which is a modular, kind of a front I/O box. That front I/O box has a motherboard with a number of these DC-XPI connectors across it. It's created an ecosystem in which they can accommodate anywhere from, E1.S drives to E3.S to GPUs to video cards to other types of accelerators, right? It's a modular ecosystem for them. Prior days, you had to worry about what form factors. This would have been, I can think of at least 3, 4, 5, 6 different SKUs that can be accommodated from this box by just altering the cable ecosystem of it and not touching the motherboard. You can imagine as a developer, right? Hey, I only have to validate one motherboard. This is awesome. Now, if you go a step further and start talking about modularity, right? And there is no firmware that's a stateless motherboard, you notice that the memory subsystem is kind of obscured. Why? Well, maybe they don't want to show it, but another good reason is it doesn't matter, right? That could be any board from any vendor. All they have to do is meet a certain minimum set of requirements. They don't have to worry about security. They don't have to worry about management. They just have to worry about meeting the interface to those things. Because if you try to get something into our data centers, there's a long list of security requirements. It's a tough haul, right? You can have something that is fantastic, it is wonderful, it is differentiating, but if the ecosystem of the data center can't consume it, it's a struggle to get in. And what you have to do is you have to circle back, go back to the drawing board, redesign it to get it in. We want to get rid of those steps to make it easier for people to get in. Here's kind of another top view of it, giving you just a little more of a view of the top of it, showing the DC-XPI connectors across it, showing these cable ecosystems. There is a vendor over on the far left in an orange shirt. If you go by his booth, you can see some of this cable ecosystem that I know that they have there at their booth. So if you want to see a little bit closer what the cables look like, stop by an unnamed vendor in an orange shirt's booth. Here's a little zoom in on it, showing the DC-XPI cable. Actually, this one's showing a 2 to 8. That could be 1 to 16. That could be 2 to 32. It's kind of up to your imagination as to what your end user point is. But the point is that you can get any number of types of endpoints onto it. So DC-XPI status. There's going to be a talk a little bit later on today. Right now, that specification has been released at 1.0. A little bit different from the PCI specification. Obviously, the connector's different, but it enables additional power and additional sideband signals that PCIe doesn't support, that some of the next generation innovations are requiring. So it gets you a little bit more flexibility, a little bit more future-proofing. Targeted for use in 2023 servers. The connector itself is not a new connector. Microsoft has been using it on a number of systems for several generations. Others have been using it as part of the EDSFF specification. So a very commonly growing presence in the industry connector. Now, I like this slide because this shows that what has happened is, and one of the advantages in creating a modular ecosystem is that we're removing barriers to entry. So this is a DC-SCM card created as part of Libre BMC, Libre being French for free. You can find this design on GitHub. It's an FPGA-based card. It's an innovation in management. Now, as a Microsoft employee, prior to DC-SCM, if you were to come to me with this card, I would say, this is really awesome. I have no way on earth of testing your technology and validating your technology. I'm going to have to design it into 85 different motherboards and see whether it's any good or not. We've removed that barrier to entry. I've had at least 2 groups show up at our booth saying, hey, thank you. I've got, we have management architecture. We have security features. If we put these on this board, spin a small board to a form factor specification, we now have an ability and a capability to ingest it into our system and at least evaluate it and determine whether something is good based on its merits, instead of just saying, well, I can't put it on a motherboard. So this is starting to see the ecosystem, enable spurring innovation in the ecosystem. Prior to this, right, if we had any type of security is, a lot of this is driving innovation. And without something like this, if we want to upgrade security, we have to wait for generational boundaries to do it. Those generational boundaries get removed. And that's a big deal as we proceed forward into the next decade, right? Because if there's a security issue, if there's a security need, we can't be waiting for generational boundaries to address them. So our call to action, right? I've shown you a few things that we're doing. We look forward to seeing what everybody else is doing, what everybody else can add to this ecosystem. We do have the DC-XPI discussion later on today. DC-SCM specification 2.0 is in works with OCP community. The goal is to add key features that fed back on 1.0 so that we can kind of expand the adoptability throughout the industry. So stay tuned. I've been very hardware centric. I look forward to what software is going to start to do on that hardware in order to enable us all to shift left and get into the markets faster. I think that's my last slide.
So if we were to lay it from the beginning to the end, DC-SCM 1.0, we have an update on it just shortly after this talk. DC-SCM 2.0, you can also have a view of it this afternoon. The subgroup that is managing that is going to present their status. DC-XPI is the interconnect, and basically it enables modular I/O. This morning we talked about a system around that. That is the modular hardware system, data center ready modular hardware system, MHS. And then on top of that, with the help of the community, we will land software to make it an integrated system. So that is the journey that we're going through. And we have done portions of it. And very soon we need your help to add and make it better. Other point to make is that these concepts are real now. In 2019, we were talking about PowerPoints. When we wanted to discuss them, we had only mechanical mock-ups. Now we have actually products, and products, high volume production based on DC-SCM is happening. Google and Microsoft have both announced that we're building products around those. The system around it is in front of us. That will be the project for next year. Hopefully we will start with some reference designs, and with reference designs people can plug and play their software, develop new software if they needed to around OpenBMC, Redfish, or any of the security apparatus that we need, and build a full system together for productions perhaps 2023 or so.
If you want to stop by the Microsoft booth, there is a server demonstrating DC-SCM. In our current generation, we have up to 12 building blocks with that design involved in it. So very exciting time for us.
One major point of all this is testability. There's a talk, there's actually a work stream going around validation and test and validation. There's Dan Frame and others have that talk. I believe that is happening at 4:15.
All right.
Did
we go over time?
Questions? I don't know. Did we? Thank you.
Oh, thank you, Nilesh.